Okay, so we've thought about the volume of a sphere, and we saw that we can actually use the formula to compute the volume of a sphere just knowing the radius. But now let's take a look at another aspect of the sphere, namely the actual surface that makes the sphere a sphere. So if you take a look at this, you can see this polka-dotted sphere. You can see that the polka dots are lying on the surface of the sphere. Well, if we were somehow able to sort of cut this all open and spread it out on the table, we would see that in this case, I guess it's made out of rubber, that rubber would have a certain amount of area. So we can actually figure out the area that's on the outside of the sphere, which is known as the surface area. Now again, it's so curved in such a beautiful way, but that curvedness makes it difficult to actually produce the surface area formula. And the formula, of course, does involve pi, since somehow there's circles involved. The surface area for a sphere turns out to be given by 4 pi r squared. Notice that, again, volume is always in terms of something cubed, and here we're seeing that area is something squared. So sort of everything is consistent in the world, but the formula is, in particular, 4 pi r squared. All right, let's see the formula in action now that we understand what it means. Okay, so the first question I want us to ponder together is to compute the surface area of a sphere with diameter 5. Okay, well, let's just charge right ahead. I'm going to do this and make a mistake. See if you can see what mistake I made, okay? So this is going to be wrong. Surface area. Here we go. There's the formula. 4 pi r squared. And units squared. What do you think? Do you see the problem with this? Well, the problem with this is I was being a little bit cavalier. I saw this 5 and thought it was a radius. But if I read the question carefully, I see it's actually a diameter. This is actually wrong. So let's see if we can do it correctly and more carefully. The surface area is going to equal 4 times pi, and now I've got to put the radius squared. What's the radius? Well, if the diameter is 5, the radius will be half of 5, which is going to be 5 divided by 2 squared. And what does that work out to be? Well, that's 4 pi times 25 on top and 4 in the denominator, and this can actually be simplified down to just 25 pi, because the 4's can actually simplify. And what are my units? Well, it's area, after all, and so I see r squared, so I see feet squared. So that's the correct answer. If you sort of got fooled into looking at the wrong answer, that's just a little sign. It's a great mistake to make. Don't feel bad about it, but just make sure that you read the question carefully and make sure you see diameter, and remember here r is radius. Great mistake. Okay, let's take a look at another example. Let's find the volume of a sphere that has surface area equal to 196 pi meters squared. Now what's going on here? Here I'm asked to find the volume. Let me remind you what the volume formula looks like. It looks like that. Well, I'm asked to find the volume, but I don't know the radius. I just know the surface area. Well, that's okay. I can use the surface area formula in order to figure out what the radius must be. So there's an intermediate step to this question. I know that 4 pi r squared represents the surface area, which in this case is 196 pi. So if I divide both sides by 4 pi, I see that r squared equals 49. And if r squared equals 49, then r equals plus or minus the square root of 49, or plus or minus 7. But wait, in this context, r is representing the radius, which means that it has to be positive. So in this context, I know that r has to be 7. Okay, great. Now, if r is 7, I can now plug it into the volume formula and see that the volume is going to be 4/3 pi times 7 cubed, which works out to be 1,372 over 3 pi. And what are my units? My units are meters, but it's volume, meters cubed. So there you have it. So here was a question which first forced me to use surface area in order to find the radius in order to compute the volume. Neat. How about this question? Let's find the surface area of a sphere with a great circle that has an area of 36 pi inches squared. Now, what's a great circle? You're saying, oh, a great circle, that's like a really good one. Well, no, actually a great circle is a mathematical term that actually has some meaning. Let's take a look at a sphere, and I will show you what a great circle is. So if here's a sphere, in fact, what I drew in there is a great circle. It's the largest circle that can be drawn along the exterior of the sphere. In some sense, it's the place where the circle has the biggest waist. Another way of thinking about it, if you thought of a globe, is it's the equator. So, in fact, that's what it means to be a great circle. And I want to find the surface area. Well, I've got the formula. But all I know is that the area of the great circle is 36 pi. Well, what does that mean? Well, if I take a look at a top view, then here's the great circle. I don't know what the radius is, but its area is 36 pi. Well, we know the area is pi r squared, and that equals 36 pi. If I divide both sides by pi, I see that r squared has to equal 36, which means r has to be either plus or minus 6. But of course, we know r is positive, so r must be 6. So that allows me to figure out that r is 6. So this sphere has radius 6. That's not the answer. That's the key to unlock the answer, because now I can find the surface area. It's 4 times pi times 6 squared, which is 36. And so I see 144 pi, and my units are inches squared. And so you can see that we can use lots of different pieces of information, sew them together, and actually answer lots of interesting, fun questions involving spheres.